Alright, miners, here's the deal. We have 3.6 billion square kilometers of Minecraft world to conquer, industrialize, and develop, and I'm sure as hell not doing it all by hand. So we're gonna have to automate, build advanced control systems, and push the limits of computer science in Feed the Beast Minecraft. Welcome to Datacraft. Before we started this episode, I thought I'd head off and try and find some blaze rods, because we're going to need them. So I created a jetpack, and along the line of x equals 0 in the nether, I built a great big 1,000-block long tunnel, looking in search of a nether fortress. By the end, I'd realised my mistake. Nether fortresses, nether structures, don't spawn everywhere in the nether. There are zones where they do and zones where they don't. And the edge of one of those zones is right along the cardinal axes in each direction. So while it's not impossible to find nether fortresses on one side of this tunnel, it doesn't happen very often, and digging along this tunnel where it is was a really bad idea. I knew all this going into it, and I did it anyway. So I came up with an alternate strategy of just start near the portal, which is close to 0, and spiral outwards with my jetpack until I found one. And I eventually did, and I dug a tunnel to it, and that brings us down here, where all of the lovely blazes live. I did a whole bunch of enchanting, and unfortunately I wasn't able to get any kind of looting on my sword, but I was fortunate enough to get Vorpal on a axe. Now, Vorpal gives you occasional high critical hit damage shots, which take off the creature's head. So it took almost no time at all, wandering around the fortress, fighting a few wither skeletons, to get 3 heads. So that's not too bad. Why are we going to all this effort, though? Especially when we have such an abundant supply of blaze powder. The answer is that we want to build ender chests from the ender storage mod. Now, these ender chests are distinct from the vanilla ender chests, and they actually predate the vanilla ender chests. They function similarly in that the ender chests share inventory with each other, except these ones, instead of being unique to a player, can be color-coded by tagging one of the 3 little white coloured notches on top with dye. Right-click in order to change one of the colours, and after that, all chests that have the same color code will be linked to each other. This is especially important because these chests can be opened by any player to see the same inventory, or any machine to see the same inventory as well. This is going to be the primary method that we use to transport items over long distances, including getting supplies to and from our turtles. Graphical glitches in the background notwithstanding. First, it's back to our good old tree farm. As you can see, I've updated it slightly to get acacia and oak logs as well as birch ones. There is a bit of a problem with the acacia trees in that sometimes they spawn in a configuration where one of the leaves connects up to the structure and stalls it out. But as you can see, we've got a fairly decent supply of all 3 of them at this point. Now, we're going to use our first designated ender chest color code, which is going to be black, white, white. And we're going to use this as our charcoal block supply, which means anywhere in the world, this is a loaded chunk, so at any time, if you put down a black, white, white ender chest, you can get as much fuel out of it as you want. We're going to put this here and connect it up to the bin in order to have an enormous cache saved up of blocks that can be sent down as soon as we need them. This is going to be the lifeblood of our turtle-based economy. Now, in order to utilize our ender chest, we need to change our code slightly. So this passage that we're using to build our branch mine, instead of depositing items in the barrel as we were, we're going to deposit items in ender chest. Everything except charcoal blocks and torches and other ender chests. And what it's going to do is it's going to find a direction it can place down the ender chest, place it down, dump everything inside of it, and pick it back up again in the same slot that it went down in. We can also as well as depositing items, we can get the fuel back out. We've got withdraw fuel ender chest, which we put inside our try refuel function. And what that's going to do is put down the ender chest containing our charcoal blocks, take out count many blocks, so 4 by default, and then pick up the ender chest again. So this way we can guarantee that our turtles will never run out of fuel, never run out of inventory space, as long as we have machines on the other side. And in addition, we're not littering stray barrels all over the place. I'm not sure what it is about recording in VS Code that makes my voice sound like it's underwater, but I hope you'll forgive me. Anyway, let's test this out. As well as the black, white, white code that we already talked about, we're going to use blue, white, white as where we're going to dump all of our stuff into. And more generally, across our whole game, we're going to use blue, white, white as the entry to our mass storage and processing system whenever we get round to building that. Let's fill the inventory spaces of Alphabot, mostly up with dirt, and set it going with our branch mine program. And you can see that immediately it detects that it's mostly full, places down the chest and dumps everything it has into it, and then pulls out enough fuel to have a few in its first slot. As it sets off, it should keep going for basically forever, until it runs out of space to put the items in or usable loaded chunk range. Then we can launch BetaBot on the other side of the hallway, and then we can return to the surface to build a dead simple output storage solution. By the way, this is the point where I hope that you're not paying very much attention to the background and won't notice the fact that I filmed everything in this episode in the wrong narrative order, and our island has changed entirely since the previous chapter. It turns out we can boost our netherite production by using a crusher to turn each ancient debris into dirty netherite scraps, and then an enrichment chamber to change each of them into actual netherite scraps. Now, in order to let the turtles do their thing, we're going to have to spend a whole bunch of time up here in the overworld with the chunks loaded. So to that end, I've decided I'm going to build a wall around the entirety of Ada Island to protect us from drowned zombies if nothing else. So we're going to build this wall around the entire island to the same height, and then we're going to try and flatten off the top of the island with a layer of grass, and then we can build to our heart's content thereon. This is the design that I've decided upon. Stone bricks and oak logs because we have those in abundance. Blackstone because it has some really nice contrast, and shroom lights because, well, why not? Alright, so thanks to the unusually hypnotizing power of episodes of Deep Space Nine, I have worked on this for several hours whilst managing to not record any footage in the process. And here's the result. The walls are complete. They surround the entire island, and for a vast majority of islands, we've taken away all of the terrain and replaced it with just flat grass, or soon-to-be grass. Now, if you look closely down there, you might be able to see the blocks disappearing one by one, and that's because to dig out most of the actual blocks that were in the way on this island, I used a device called a builder from the RF Tools mod. The block itself was fairly expensive, and in order to get it to mine things and pick up the blocks, you've got to give it a quarry card, which is even more expensive. But at the end of the day, it's just a few diamonds. The machine is pretty simple. You give it a power source on the side and an output slot on the top, and you program the shape card to dig the coordinates you want, and it just digs it out. I'm in two minds about this. On the first hand, it's really cool, and it's going to allow us to do impressive terraforms at a much larger scale than we otherwise would. On the other hand, it does feel a bit like cheating. So I think whenever possible, I'm going to avoid using this in future in favor of the more manual, but still way more fun, programming of turtles to do the task. One other quick project that I threw together is a medium-scale RF producing generator. Basically, the way this works is we have magmatic dynamos, which can turn 1 bucket, or 1,000 millibuckets of lava, into 100,000 RF. On the other side, we have magma crucibles, which can turn netherrack into 1 bucket of lava for 60,000 FE. Which means, at the price of 1 netherrack, we can turn it into lava and turn it back into fuel again for a net gain of 40,000 FE. So I collected a whole bunch of useless netherrack, and I'm turning it into power and a considerable quantity of lava, as you can see here. And over on the other side, we have our fueling stations. We'll put a power cube in there, and it'll keep full, and we'll put other power cubes on the side when we need to charge them. We also have a comparator, and the comparator is fed an input on the side by an analog lever from Create, which basically allows you to customize the redstone level that it outputs. And overall, this system ensures that when the power cube fills up completely, the comparator gets triggered and it turns off all our magmatic dynamos, or otherwise we'll have wasted cycles and wasted lava when the system is full. Lastly, I went fishing. And not because we need any fish, or because we need any treasure, but we actually care about some of the junk. I was trying to find a lily pad. And the reason for that is because I like having lily pads around. They're a very useful block to have around when you need to stand on water all of the time, which I was thinking of using for farms. Now, So I converted this great big mechanism back into the mode that we had in a previous episode, where we were generating weathered limestone, because it gives us a byproduct of lots of bone meal. And with this bone meal and this 1 lily pad that we start off with, in addition to a water source and energy, we can use ThermalMod's phytogenic insulator to turn 1 lily pad into multiple lily pads, feed it back from the output into the input, and generate as many of these things as we still have bone meal and power to provide. And finally, after all that's done, it's time to retrieve our turtles. Now, I'd let the things run for a long time at this point, including quite a while when I was AFK, and the tunnel has extended considerably. Bring it back to the surface, we can look at the output chests. Considerable amounts of iron and fluorite in this bin, as well as other blocks and cobblestone, which had to be emptied out a couple of times. And in these chests, you can see we have insane quantities of all kinds of resources. So I'll just show you through all of them. In addition to that, you can see a few diamonds there. I ran down the passageways, and remember, we didn't use depth first search to collect the diamonds, so I was able to use a silk touch pickaxe in order to pick up all of the veins that were intersected and not cleaned up. And as you can see, we don't have very much of a diamond problem anymore. Okay, so altogether, that's probably about enough progress for today, but I'm going to let you in on what we're going to be doing next time, mostly because there's going to be a very long AFK portion that I want to start getting out of the way right now. One thing that I noticed whilst I was trawling through just enough items and all of the recipes and different types of things we have available are some interesting properties of prismarine crystals. Anyway, so along with their regular usage in the main game, you can use them to construct prismarine lanterns. It's also possible to use the Create mod to crush them down into a bit of glowstone dust, which can be formed back into blocks of glowstone, which means large numbers of prismarine crystals, free glowstone. In addition, there's a lapidary dynamo, that allows us to generate power from prismarine crystals, which, if we build a good enough automatic farm, should be virtually free. In addition to that, we can build underwater rails with the things, which I have no idea how they work, but that sounds pretty awesome to me. So our next project is to turn that great big ocean temple that's just over there into an ultra efficient prismarine farm so that we can get enough shards and crystals to make unlimited prismarine lanterns, and glowstone, and power. And since this is useful for power, there's not really any way that we can go overboard here. So I've been coming up with and researching some of the most efficient and productive prismarine farms I can find, and I don't think you'll be disappointed. To get that process started though, we're going to need to dig out the whole area that's currently resided by the Ocean Temple, and rather than trying to do that all by hand, which sounds kind of tedious and manual, and if this series is anything, it's not tedious and manual, and of course we're going to use turtles here instead, which I think is going to be fun. That's going to take a while though, so I needed to finish up this branch mine and get started on it. Let's begin.